Let's say that f of x is equal to x over the square root of x squared plus 1. And I want to think about the limit of f of x, as x approaches positive infinity, and the limit of f of x as x approaches negative infinity. So let's think about what these are going to be. Well, once again, and I'm not doing this in an ultra-rigorous way, but more in an intuitive way, is to think about what this function approximately equals as we get larger and larger and larger x's. This isn't the case if we're getting very positive x's, very in positive infinity direction, or very negative. It's still the absolute value of those x's are very, very, very large as we approach positive infinity or negative infinity. Well, in the numerator, we only have one term. We have this x term. But in the denominator, we have two terms under the radical here. And as x gets larger and larger and larger, either in the positive or the negative direction, this x squared term is going to really dominate this 1. You can imagine when x is 1,000,000, you're going to have 1,000,000 squared plus 1. The value of the denominator is going to be dictated by this x squared term. So this is going to be approximately equal to x over the square root of x squared. This term right over here, the 1, isn't going to matter so much when we get large, very, very, very large x's. And this right over here, x over the square root of x squared, or x over the principal root of x squared, this is going to be equal to x over, if I square something and then take the principal root, remember the principal root is the positive square root of something, then I'm essentially taking the absolute value of x. It's going to be equal to x over the absolute value of x for x approaches infinity or for x approaches negative infinity. So another way to say this, another way to restate these limits is as we approach infinity, this limit, we can restate it as the limit, this is going to be equal to the limit as x approaches infinity of x over the absolute value of x. Now, for positive x's, the absolute value of x is just going to be x. It's just going to be x divided by x. So this is just going to be 1. Similarly, right over here, we're taking the limit as we go to negative infinity. This is going to be the limit of x over the absolute value of x as x approaches negative infinity. And remember, the only reason why I was able to make this statement is that f of x and this thing right over here become very, very similar, or you can kind of say converge to each other as x gets very, very, very large, or x gets very, 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 very negative. Now, for negative values of x, the absolute value of x is going to be positive. X is obviously going to be negative, and we're just going to get negative 1. And so using this, we can actually try to graph. We can actually try to graph our function. So let's try to do that. So let's say that is my y-axis. This is my x-axis. And we see that we have two horizontal asymptotes. We have one horizontal asymptote at y is equal to 1. So let's say this right over here is y is equal to 1. Let me draw that line as a dotted line. We're going to approach this thing. And then we have another horizontal asymptote at y is equal to negative 1. So that might be right over there. Y is equal to negative 1. And if we want to plot at least one point, we could think about what does f of 0 equal? So f of 0 is going to be equal to 0 over the square root of 0 plus 1, or 0 squared plus 1. Well, that's all just going to be equal to 0. So we have this point right over here. And we know that as x approaches infinity, we're approaching this blue horizontal asymptote. So it might look something like this. Let me do it a little bit differently. Let me do it a little bit. There you go. Clean this up so it might look something like this. Oh, that's not the color I wanted to use. So it might look something like that. We get closer and closer to that asymptote as x gets larger and larger. And then like this. We get closer and closer to this asymptote as x approaches negative. As x approaches negative infinity. I'm not drawing it so well. So that right over there is y is equal to f of x. And you can verify this by taking a calculator, trying to plot more points, or using some type of graphing calculator or something. But anyway, I just wanted to tackle another situation where we're approaching infinity or negative infinity, and we're trying to determine the horizontal asymptotes. And remember, the key is just to say what terms dominate as x approaches positive infinity or negative infinity, to say, well, what is that function going to approach? And it's going to approach this horizontal asymptote in the positive direction and this one in the negative.